This is exam 3 for fall 2020 Physics 101. In this figure, the mass has a speed of 3 kilograms and has a speed of 4.0 meters per second at point A. It goes down the slope. What type of energy does it have at point A? Well, at point A, it has potential energy, and I know that because the height is bigger than 0. Remember, potential energy we have as m times g times h. And it also has kinetic energy. And I know that kinetic energy because the kinetic energy is equal to 1/2 mv squared. And since its speed is bigger than 0, I give that right here at 4 meters per second, that means that the kinetic energy is bigger than 0. So it has both kinetic and potential energy. Same situation, what is the speed of the object at point B? So I would say that the total energy of it here is equal to the total energy here. That is potential energy plus kinetic energy. Those are both at point A. Will equal to, it only has kinetic energy at part B because the height of the object is equal to 0, so the potential energy of the object at that point is equal to 0. So I'm going to go and write in this. I'm going to use the numbers as m times g times 5, right there, plus 1/2 m times 4 squared is equal to 1/2 mv squared. The m's all cancel out. I can get rid of those. So I have 50 plus half of 16 is 8 equals 1/2 v squared. That's 58 times 2, that's 116 equals v squared. So v is equal to 11. So that is A. Number 3, same situation. What is the speed of point C? So this is really similar to what we did before, except now I have both potential energy and kinetic energy at this point. So I'm looking at the full conservation of energy here because I have all 4 elements involved, the potential and the kinetic at points A and C. So I have m times g times 5 plus 1/2 m times 4 squared, just like I had in problem 2. Plus m, or rather equals, m times g times 2, that's this, plus 1/2 mv squared. I'm looking for that v. So the m's all cancel out because I can divide through. I get 58 over here minus 20 equals 1/2 v squared. That's 38, 60, 76. Square root of 76 is equal to v. That's going to be this, yeah. Cardboard box with a mass of 3 kilograms has a speed of 2 meters per second as it slides across the floor. The coefficient of kinetic friction between the floor and the box is 0.2. How far does the box slide before coming to rest? Now, there are ways to approach this from a kinematics and Newton's laws approach, but it's much easier to approach this from the energy perspective. That is that the cardboard box has so much kinetic energy as it starts its sliding across the floor. And then in this sliding, that kinetic energy is taken away by the work done by the kinetic friction. And so we set our kinetic energy equal to the work that's done by friction. And since we're looking for how far, then when we solve that for D, we'll have our answer. So kinetic energy is 1/2 mv squared. Now our frictional force is a little bit tricky because I know that friction is equal to mu times the normal force, and I give you the normal force, or excuse me, I give you mu, it's 0.2. The normal force, because it's on a horizontal surface, is just going to be equal to the weight. So that's 3 times 10, or 30 newtons. So 0.2 times 30 is 6 newtons. So that's equal to 6 newtons times the distance, d. So I have 1/2 of 3 times the speed, which is 2 squared, divided by 6 is equal to d. Gives me a 2, gets rid of that. D, half of 2 is 1 meter, so 4 is A. 8,000 Newton car is traveling at 12 meters per second along a horizontal road. When the brakes are applied, the car skids to a stop in 4 seconds. How much kinetic energy does the car lose in this time? All right, so one thing you really need to be careful of is recognize that this, excuse me, Okay, sorry about that. So one thing you have to be careful about is recognizing that the excuse me, the mass of this object isn't given, it's the weight. And so the mass is equal to 800 kilograms, because 800 times 10 gives me 8,000. That would be the weight. Okay, so I want to know how much kinetic energy does it lose? Well, how much kinetic energy does it have if it's 800 kilograms traveling at 12 meters per second? That's going to be 1/2 of the mass, 800 kilograms, times 12 meters per second squared. So that's 400 times 144. I get 58,000. So A is the right answer there. This toy car can travel two paths, A or B. The car does experience a frictional force. Okay, so a frictional force is not conservative. That means that it's path dependent. It depends how long the path is to determine how much energy is lost or is lost due to the frictional force. So the longer path is going to lose more energy. Then the statement that's true is that the velocity of the car traveling path A is going to be larger at the end. And that's because it has a shorter path, even though my beginning and ending are at the same height, right? So I have the same change in energy due from potential energy, but the loss of energy due to the frictional force is more in path B because it's not a conservative force. Two trailers with mass 500 and 2,000 are being pulled at the same speed. What is the ratio of the kinetic energy of y with respect to x? You really need to know how to do ratios. We don't talk about this that much in class, but ratios are important. They come up on standardized tests a lot. So remember, ratio is 1/2, or the kinetic energy is 1/2 mv squared. That means that the kinetic energy is proportional to the mass in a linear way, directly proportional with a linear proportionality. Then the ratio of KEY to KEX would be 2,000 to 500. Or if I simplify that, I get 4 to 1. So C is the right answer. Which expression represents power? Remember, power is equal to work over time, or you can think of it as energy over time. So this is potential energy, this is work, this is kinetic energy. So B is the right answer for number 8. Okay, a spring-loaded gun shoots a 0.02 kilogram ball. The spring has a spring constant of 250 newtons per meter, and a person shoots the ball and gives an initial speed of 30 meters per second. What was the compression of the spring in the gun? So I had this thing, and it was all compressed up. And then it released the ball and gave the ball a speed of 30 meters per second. I want to know how much was this compressed. This is x equals 0, and then this is x equal what? So it initially has potential energy, elastic potential energy, and then it converts all of that into kinetic energy. Look, I can get rid of my halves. I'm looking for x. X is going to be mv squared over k, square root of that. That is 0.02 times v squared, which is 30, divided by k, or 250. That's right here. I get 0.27. That's in meters, though, so since I'm looking for this in centimeters, the answer number 9 is B. 1.5 kilogram crate falls from a height of 2 meters onto an industrial spring scale with a spring constant of 150,000. That's a K. And I want to know at the greatest compression that it has. So I have this object, there's a spring above it, and then when it falls, it compresses that spring, and I want to know what does that scale now read? And this is how a scale works, often anyway, is you have a spring, you step on it, the spring compresses, and then it converts that into some force. So Two steps in this is first I need to figure out what is x. And that's just like what we did before, except now I'm setting my gravitational potential energy equal to my elastic potential energy. mgh equals 1/2 kx squared. And I solve that for x. So that's going to be the square root of mgh over 1/2 k. 1.5 times 10, that's g, times 2, divided by 1/2 of 250. I get 0.49 meters. Then I want to find what force is that, so I would say the force is equal to kx. I know that k is, oh my god, I made a mistake here, I'm sorry. I was thinking of a different problem, so let me go back and fix this. I just realized that k is not 250, that k is 150,000. So that would mean that this is 75,000. I get 0.02. 0.02 meters, or 2 centimeters. And now F is equal to K times X. K is 150,000 times 0.02. That's going to be 3,000 newtons. So 10 is A. Be careful as you're going through these that you don't make these same mistakes. Just being very methodical in how you read the problem and how you pull information from the problem. That's not just good advice in this physics course, but it's good advice on all standardized tests. In fact, a lot of your standardized tests are not really testing your content knowledge so much, although for the MCAT you definitely need to know your chemistry and your physics and your biology, but they're testing more so is your ability to analyze and reason and think critically. Okay, in this figure, the spring has a spring constant of 1,000 newtons per meter, and the hand compresses the block spring system to the left by 50 centimeters. What is the force F? So this is using Hooke's law. F is equal to kx. I'm not going to worry about the signs right now. We'll figure that out in a bit. But I have a k of 1,000 newtons per meter, and then x is 50 centimeters. I need to convert that to meters. Never going to go wrong converting to SI units. And remember, to convert from centimeters to meters, I just moved that decimal place over twice. So that's 500 newtons. And then notice I have two instances of 500, a positive and a minus, and I'm looking for the force exerted on the block by the spring. Now the spring is going to push on the block in that direction, which is opposite the direction of the displacement, and that is a positive displacement, so C is the answer to number 11. You raise a 20 kilogram mass from ground level to a height of 2 meters. How much work have you done on this object? Well, two ways you could think about this. You could think about the work done by the gravitational force, which would be the mass, 20, times g times the distance, which is 2, that's 40 times 10, or 400 joules. Or you could say, well, how much have I changed its potential energy, which is equal to mgh, which is going to be, 20 times g times 2, which is 400 joules. In fact, this is how we derive the expression for gravitational potential energy. Anyway, the answer is going to be A for 400 joules. Consider this block on an inclined plane. The force F pulls the block across a distance of 2 meters while the frictional force opposes the motion. What is the total work done on the object? A couple different ways you could think about this. You could figure out the work done by this force. Work is equal to F times D, and 20 times 2 meters. It acts over 2 meters. That's 40 joules. And then you can figure out the force done by this work. The work done by the frictional force is 5 times 2, or 10, but of course this is a frictional force, so it's going to be negative. The force and the displacement are opposite one another, so I have an angle of 180 degrees, and the cosine of 180 is -1. And then I have 40 minus 10 will give me my total work of 30 joules. So 13 is D. The other way to approach this is you could figure out the net force, and the sum of the forces would be F minus F, which would be 20 minus 5 or 15 newtons. That's the net force acting on this block. And then the work that's done by that force would be 15 times 2, and you'd get 30 joules. Either way is fine. I prefer the former, the first way, just because it makes more intuitive sense to me. Now, consider this block in an incline plane. Same situation. What is the change in height for this object? A couple of ways that you could do this. Actually, let me pause this for just a second. And so a couple of different ways that you could approach this. One, you could just take the geometric approach and say, well, this distance is 2 meters and this angle is 30 degrees, and I want to know what is this. And so I could say then that delta y is equal to 2 sine of 30. Just doing basic trig. And that's equal to 1 meter. And that would be correct. So the answer is 1 meter. Another way you could say is, hey, I know that I've done a total amount of work on this object of 30 joules. And that's what I found in the previous problem. The change in energy of this object is 30 joules. And all that energy has to go into a change in potential energy. And so I would say 30 joules equals the mass, which is 3 kilograms, times g, which is 10 times h, and then I get h equal 1 meter. I prefer the second just because it, you have a better grasp of the energy, but the first method is okay too. A boy pushes his wagon at a constant speed along a level sidewalk. The graph below represents the relationship between horizontal force exerted and the distance the wagon moves. Now, in short, this graph is showing that the force is constant at 30 newtons. And so this graph doesn't really change the problem. I don't really need the graph, but I want you to be able to read a graph like this and be able to interpret it. What is the total work done on the wagon as he pushes it across a distance of 4 meters? So work is equal to force times displacement. It's always 30 newtons. The displacement is 4 meters, and that's equal to 120 joules. Now, I could have gotten this by saying what is the area under that graph. And so work is equal to the area under a force versus distance graph. That's kind of useful actually, because what if I have a force that is not constant? What if it's like that? And I want to know what is the total amount of work that's done by that force over a certain distance. Well, in this case, I take the area under that graph, and that is a variable force, a force that changes over distance, but now I can figure out what is the work done in a fairly simple way just by doing the integral or, just finding the area under that function. A box moves up an inclined plane with a tension force and a frictional force. Which of these statements is true? So I know it's moving up the inclined plane, either with a constant velocity, with some velocity, maybe an increasing velocity. I know that F cannot be bigger, the frictional force can't be bigger than F, just because if that was true, it wouldn't be moving up the inclined plane. It would be static, or I'm not even sure how the frictional force can be bigger than the opposing force. It's not really possible. The frictional force F increases as the block accelerates. No, that's not true. The force F does positive work. Okay, yes, because the force and the displacement are in the same direction. The frictional force is in the negative x direction with a typically chosen coordinate system. And to go back to what we did here with our inclined planes, we typically choose this coordinate system where that is positive x and this is minus x. So D is not the right answer. So you should have been able to pick that C is the right answer there. What's the SI unit for work done on an object? Okay, work is force times displacement. That is mass times acceleration times displacement. That's kilograms, meters per second squared, meters, so it's kilogram, meters squared per second squared. D is the right answer. Which of the following groups does not contain a scalar quantity? Okay, I'm going to circle the scalar quantities. Scalar quantity, scalar quantity, scalar quantity, scalar, scalar, scalar. I feel like Bueller. Bueller. So B is the right answer. All three of those are vector quantities, and all the A, C, and D, they all have scalar quantities. An object moves in a circle at a constant speed. The work done by the centripetal force is 0 because, well, the reason is that the centripetal force is perpendicular to the velocity. Might remove that question. So a person has a mass of 90 kilograms and is sliding forward on a frictionless track at 2 meters per second. A person catches a medicine ball of 10 kilograms traveling in the opposite direction of their motion with a speed of 8 meters per second. What is the person's new speed? So I have the initial state. I have a person traveling at this speed at 2 meters per second, and they have a mass of 90 kilograms. And then there's a ball going in this direction. Somebody's thrown it towards them. It has a mass of 10 kilograms and is traveling in the opposite direction at 8 meters per second. And then the person catches the ball, hopefully, and I want to know what is the person's new speed. This is the situation that I have. This is my final state here, and that's my initial state there. So I have 90 times 2 plus 10 times negative 8 is equal to 90 plus 10 times v. It's 180 minus 80, that's 100, equals 100 times v. So it's going to be 1 meter per second to the right, positive 1 meter per second. So number 20 is C. Consider this inelastic collision. What is the final speed of the 4 kilogram mass? So this is similar here. I'm just going to put in the numbers. 3 times 2 plus 1 times, excuse me. I'll do it mv. 2 times 3 plus 4 times negative 1 is equal to 2 times negative 1 plus 4 times v2f. I want to know what v2f is. That's 6 minus 4 is 2 equals negative 2 plus 4 v2f. Looks like v2f is equal to 1 meter per second. 500 sack of coal is dropped into a 2,000 kilogram railroad flat car, was initially moving at 3 meters per second. The sack rests on the flat car, and the speed of the flat car is what? So this thing changes mass, not velocity. Well, it changes mass, and then I want to know how that changes the velocity. So the original momentum is 2,000 times 3. And then the final momentum is going to be 2,500 times VF. 6,000 divided by 2,500 equals VF. I get 2.4 meters per second. So this thing slows down when it gets this extra mass on it. Gwen weighs 150 pounds, Amy weighs 50 pounds. There's Gwen, there's Amy. They're standing still and they push off. So right now they have speed equals 0, and so their initial momentum is equal to 0. But then they push off. Amy goes away at 10 meters per second. And I want to know, how fast does Gwen go away? Well, I can think about this because Gwen has 3 times the mass of Amy. So she's going to have 1/3 the speed of Amy. So I can look at this right away and say the answer is 3. But if I really wanted to look at do this correctly, I can do this. First of all, I just want to say that these are in pounds, but I'm going to treat them like, which is a weight, but I'm going to treat it as if it is a mass. So the initial momentum is 0, and then the final momentum is going to be 150 times VF, that's the speed of Amy, plus 50 times 10. And so VF is negative 500 divided by 150, which is 3.3, or 3 meters per second. So A is the right answer. 20 milligram mass is traveling at a speed of 10 meters per second. You apply a force of 20 newtons until the object comes to rest. How long do you have to apply the force? Well, F is equal to delta P over delta T. I have a force of 20 newtons, and My change in velocity is 0 minus 10, so that's going to be 20. That's kilograms times delta V, which is 0 minus 10. That's the change in velocity. And then I have time. So these 20s cancel. Leave 1 on either side. That means that t has to be 10 seconds. I guess really to be correct here, the force would have to be in the negative direction. Okay, so a crane drops a 0.3 kilogram steel ball into a steel plate. I'll let you read that. We've done this problem before. So F is equal to delta P over delta T. I want to know the average force. The mass is 0.3 kilograms times 3.2 minus negative 4.8 divided by T, which is 0.03 seconds. 3.2 minus negative 4.8, that is 8. So 2.4 divided by 0.03 is 80 newtons. Force is the time rate of change of momentum. That is F equals delta P over delta T. Impulse has the same dimensions as momentum. And which of these statements is true? Energy is a scalar, momentum is a vector, so B, number 28 is B. Okay, so I'm going to take off that one question about centripetal forces. Who knows, you might see it on the next exam, but that's all.